My name's Wade Maranowski. I'm just going to do a little bit of a history of how I came to robotics and what it has led me to do, and showed my robotic works overseas and done many international journeys, as well as gotten grants from the government to do creative robotics projects. So what I used to do was I worked a lot with computers to do audio-visual projections. So I did music and visuals with computers and triggered them via the keyboard. So I used the keyboard and the computer as a performance-based instrument. And I got sick of working at the computer, and I wanted the computer to be in space so people could physically experience algorithms as well as the movement of robots in the context of the gallery. So I wanted to break out of any science-based laboratories, and I wanted to give people a first-hand experience of robots. So I did a doctorate in creative robotics, and my theory was looking at the uncanny. So the uncanny, it pertains, or could be explained in a simple way, is that why are people scared of robots? So people are scared of robots for a few reasons, but we'll find out as we progress. So way back in 1906, the psychoanalyst Jentz stated a very good instance of the uncanny is whether an animate being is really alive, or conversely, whether an object might be in fact animate. For example, the impressions made by waxworks figures, dolls and automata. So automata are the earliest types of robots that developed in the 18th century. And so people who first saw these automatas were scared, and because if you unpack this statement, it's because when dead things become alive, or when inanimate objects start to move. So everyday objects start to move around is a concept that I've looked at, and you'll see later on a wardrobe following people around a room. So going back in time, these are the early automatas of the 17th century. So they wrote things like, "I think, therefore I am," and also played musical instruments such as this robot. And I was deeply impressed by the way that they were decorated. So they were dressed in the kind of Renaissance style dresses of the times. And this really influenced me to dress up my robots as well. So one of the other things that the theories that I found was that you shouldn't design robots too lifelike, otherwise they'll fall into this theory called the uncanny valley. So if you design robots too lifelike, they become scary. But if you design robots that look like robots, people have more feelings for them. They can express empathy towards just an object that looks like a mechanical toy, such as this one by Kuro, a Sony toy robot. So people like these robots more than, say, these robots, which look like humans. And this is a Japanese roboticist who designs robots to look like humans, and obviously they look a bit more creepier. So they scare people, and so there's a balance between how we should design robots. This is another person who has explored lifelike or human-like robots. This one is David Hanson's version of Philip K. Dick, who wrote the novel Do Androids Dream of Electronic Sheep, which became the film Blade Runner. So before I started my robotics, I went and studied with this artist named Bill Vaughan, and he creates robots like this that shoot laser beams and hang from the ceiling, and he creates an atmosphere full of smoke and sound to create like a post-apocalyptic world which people can experience. So his version of robots is that he wants people to feel sorry for these machines. So people experiencing his work have expressed that they feel sorry for his machines, and he's interested in inducing empathy towards something that just looks like a machine, but because it twitches and moves around, people can start to associate and have feelings towards it. So I didn't really like his artwork at the time, but I wanted to explore a different realm. So this is one of the first robots I built in his studio. So it's very basic. It has two sensors here, and these are called ultrasonic rangefinders, and they can send out a signal which is a high frequency sound, and it shoots back the sound, and the sensor can detect the distance of the walls. So when the sensor, or the program that I wrote in a small microcontroller called an Arduino, it turns the wheels around so the robot never bumps into any walls. So this was my first ever robot back in 2007. It's called Prototype 1. And this is my second one, and it uses a camera. This time I've included a camera. You can see that there's just recycled BMX bike tyres, some batteries from an old toy, and then I've got 4 sensors now, so you can see at the back, at the front. And this one had a camera, so I could drive it remotely. So using a wireless camera coming into my computer, I can drive it remotely using a Bluetooth module or a Wi-Fi module, as I used later on. So this is like a Mars rover, but a hand-built Mars rover. And this is a performance. So here I'm introducing the dressers. And in this performance with 2 robots, I was controlling them via one laptop was for controlling them. And I used a Bluetooth Arduino at this stage. And because I was using Bluetooth, there was a lot of noise, and the everyone else's mobile phones created interference. And so the robots ended up crashing, and it was a disaster. So I just wanted to show you the process of some of the early works and the disasters and failures that I made. So it's not always going to be a success, but the important thing is that you learn from your mistakes. So after this one, I developed a stronger system which used the internet as well as the Wi-Fi communication. So in this work, I was sitting at home, and I Skyped into the robot itself. So I can drive this robot around while sitting at home. So imagine I'm sitting in this room and I've got a robot in your classroom, and I was able to drive it around and also communicate with you, so I can talk to you. But people didn't know how this robot was operating, because they thought it was an intelligent robot. Some people thought it was an intelligent robot, and some people thought I was in the next room, but I was actually miles and miles away controlling it via the internet. And I put a voice effect on my voice, so I sounded more like a robot. And it's called the discrete charm of the bourgeois robot. So I was looking at this notion of a robot that's upper class and snob, and it's playful. So I'll just play you a little bit of this. So the sound is cool.
What's your name, sir? What's your name, sir? Interesting. Interesting. Boris. The bourgeois world. Forever. Time is endless. Forever. Time is endless when you're from outer space. When you're from outer space.
So how long are you here for today?
5 o'clock. 5 o'clock.
What's going on?
I am the bourgeois world.
Wait and see.
I am the bourgeois world.
Wait and see.
I love you deeply. I love you deeply. Thank you.
So as you can see, I'm moving the robot towards him, and I'm also talking to him, and he thinks that somehow that the robot is acting by itself. So this was in some sense a trick and that I wanted to experiment with to see how people would understand robots in everyday, in a gallery context. So after that, I did a new work called The Hosts, a masquerade of improvising automatons. So this time they're 2.3 meters tall, and there's 5 of them. They all have a laptop inside, and all the laptops are on I can connect to from one master controller or one laptop that speaks to them over Wi-Fi. And they have an array of ultrasonic rangefinder sensors at the bottom, which allow them to operate by themselves. And they have sound and they have lights. And I also programmed the sound and light within the space. So people walk into this experience. And this is to show you the scale of the robots. I also have a video of this, but I'll just talk over the top. So this is in 2009. So here you can see the influence of the early automata that I was talking about at the start of the talk. So the early 18th century robots had this European style dresses, and that's why I continued to explore that, but in a contemporary setting. And also the difference between the early robots and these robots is the scale. So people are quite taken back or a little bit scared of the scale of these robots coming towards them. And so it's like a masquerade ball for robots, so each one has a different costume. So as you can see, they're coming towards the people here. So one of the things that people said to me whilst experiencing my work was that they thought that the robots were responding to them, when in fact they were operating on their own accord. So I came up with this concept that the robots were narcissistic, that they only cared for themselves. So imagine in the future we create these robots, and because everyone expects robots to do their dirty work for them, to vacuum the floor, to clean the dishes. But what about the fact that robots might want to just be robots and not care about humans? So this is the further development of that, and this is called the bourgeois robot number 2, and it has a different dress and it has a larger mirror, so it looks at itself in the mirror. So the concept is that it's a narcissistic robot that cares for itself. Also, in response to this idea that people thought robots were interacting with them in my previous work, I decided to develop this work called the Aconchi robot. And the Aconchi robot actually follows you when you're not looking at it. So it uses a Kinect camera. Is anyone familiar with a Kinect camera for Microsoft? It's for games, so you can play games using your hands. And it also detects your face. So that part of the technology was of interest to me because I could detect faces. And when the robot detects your face, it turns you into this symbol, a blob, and when the people turn around, it follows that blob. So the distance of you, it comes up behind you and starts to follow you. So I'll just show you a video of that, because it's easily more explained through the video. So this was exhibited in China at the National Museum of Art in Beijing. And what's interesting about that particular museum is that it gets thousands of people per day. This is at a slow day when there's only the people who work there. So it's in the morning. So here you can see this guy's getting followed by my robot. But he has to walk slow because it's not that intelligent. And it also needs to keep him in its point of view, so the field of view. So this is the Conchi robot that follows you when you're not looking at it. So it makes you walk slow, it makes you contemplate the time and space that you're in, and it allows you to be more meditative. But the story I was going to tell was that in China they thought it wasn't working because there was thousands of people in the gallery, because so many people were looking at the work that they decided that it wasn't working properly. But because the robot has a certain behaviour, it needs not as many people looking at it at once. So as you look and turn around, it'll stop. So that's the Conchi robot, and it uses ultrasonic rangefinder sensors, wheels and motors, batteries, and a Kinect camera inside here. So it's designed to look like an everyday wardrobe or a shipping crate. And this idea that the inanimate object becomes animated is something of what I was interested in that particular work. Now this particular work is called Robot Opera from last year, and it involves 8 autonomous robots similar in size to my previous robots, but this time I was exploring the aesthetic of the machine. So machine aesthetic, just raw materials. You can see steel, it's all see-through, and I wanted to play with the elements of just movement, sound and light. So imagine an opera for robots. People come in and they interact with these robots that drive around by themselves, and they also can be followed by these robots. They also do like a sound and light show, which I'll show a bit of now. And so this is at Carriageworks in Redfern. It was a large-scale production involving dramaturge, lighting designers, musicians, and electricians. So electrical engineers also helped me design this piece. So it's a fully 30-minute choreographed performance for robots, or autonomous machines, you might consider them. They don't particularly look like robots. So some people who came to the exhibition thought they were going to see CP30 singing a song. So as you can see here, the audience are waiting to interact with the robots. The robots have a computer on them that shows what the robots can see. And whenever the robot sees a human, it says, "I can see a human," in a robot voice. And also flashes a blue light at them. So later on, they start to move around and move the audience. So the idea is that the robots move the audience into a particular configuration, and then they go a bit haywire and start to spin around. So this signifies the robot out of control, which is another kind of a trope of science fiction where robots take over the world. So that was something I wanted to explore in this particular work. Now this work is a robot that throws hot chips to seagulls. So I was a bit sick of working inside the gallery context. I wanted to make work that interacted not only with humans, but interacted with animals. So this work, you've put hot chips into the catapult, and the catapult throws hot chips to the seagulls. So this is a robot for the outdoor environment. And yes. Now this one is called Moonwalker, and this is the final piece which I'll show. And this is currently on exhibition at the Museum of Contemporary Art in Sydney. And it's in this exhibition called New Romance, Art and the Post-Human. So what do we can think about when we think about art, or what do we think about, art in the future, or the concept of post-human What will it be like once we have robotic parts within our bodies and when we're cyborgs? Or would you consider us to already be cyborgs due to the fact we have a lot of laptops and technological devices such as mobile phones that we use all the time? So this concept of the post-human is what we explored in this exhibition at the Museum of Contemporary Art. So this robot is like a globe with skeleton legs, and it does a dance similar to a moonwalk, similar to Michael Jackson, and explores this idea of what it will be like once we're able to connect to each other via our brains. So the prediction by Ray Kurzweil is that we'll upload our consciousness to the cloud and we'll be able to talk to each other without mobile phones, just with our brains. So that's something, this is the visualization of that. So maybe our brains will be so big and maybe we won't be able to navigate spaces because we'll be too busy communicating with other people at the same time as walking around. So this is a visualization of walking around whilst also talking to multiple people. So in that sense, I'm proposing that we'll be able to be in multiple places at once. So that's it. Thank you for your time. I hope you enjoyed my presentation. I'm looking forward to your questions. So this particular robot, the Moonwalker, is very basic. It just programs 6 different motors to run back and forth. And there's also a little brake, so there's a timer in there. So if you wanted to get started, I would recommend buying an Arduino, which are $30. So that's ARDUINO. And you can test out multiple example codes and programs. And that's the best way to get started, and that's how I got started. If you're so inclined, I would recommend you do electronic engineering. If you could also do, which is at Macquarie, you could also do video gaming at Macquarie, an interactive course, interactivity and online gaming. And otherwise you could come and study with me. I work with other people for the more complex robots, and when I'm doing I do all the prototyping, and the way that I do that is by using example code online and modifying that example code, and that can be found through just searching and also through the examples on the Arduino homepage. Yes, so this one here, that's actually me. This is me on Skype, and this is my interface. So I can, if you can't see that, but it says forward, left, reverse, and speed, and this accelerate, speed, and I can type in a few other things. And this is the robot that I'm controlling from home, and this is through a webcam basically, and a webcam is on wheels and has a battery. There's also a laptop in there which allows me to connect to it through the internet. Yes, I'm currently thinking about different ways of taking it further. I'm interested in doing like a gymnastics style Olympics and getting robots into the Olympics. Yeah, so if we go back here, this is my first robot. So you can imagine that it took some time, maybe 1.5 years to get to this stage, where there's 5 larger than life-size robots. So I've built all of these robots, and they basically look like this inside. It's just MDF and wood, but some of the parts you can purchase, and some of the places where I purchased the wheels is a company in the US called Parallax. But as you can see in this one, these are just found motors attached to BMX wheels. So you can build them from rubbish. Yes, so I started a PhD in 2007, and it was a creative project PhD. So yes. Yeah, all of them could be improved on. I'm working on robotic arms. As you can see, the final work that I've done is called the Moonwalker, and that's the first time I've moved into articulation of limbs. So that has moving legs, and what I'm interested in is doing legs and arms for future works that, enter the Olympics. I was doing a lot of work with computers, and I got sick of working with computers and sitting down at the desk, and I wanted to be more sculptural. I was working with computer-based installation in gallery contexts, but I wanted for both myself to become more physical in the studio. I wanted to be able to work sculpturally and in the space, and I wanted people to experience robots for the first hand. So instead of seeing them on screen and in the movies, I wanted to see robots inhabit exhibition spaces in everyday life. Well, people have been asking me why I got into robots, and back in the 80s there was a phenomenon called breakdance, and that's why the new work is called Moonwalker, because when I was young I did breakdancing courses. So in breakdancing, and we learnt the moonwalk, and we learnt to do the robot dance, and I think that was one of the key points to drive me into making robots, but also the fact that we never get to see robots in real life. We always see them in the movies. You can build floating devices already, so all you have to do is connect them up to tele-operational devices. Like Nikola Tesla, he invented a remote-controlled submarine in the 1940s, so it's pretty much already been done. There's also a lot of different robots that you can control underwater. A lot of companies such as Apple and Microsoft are working very hard to be able to standardize this process of building robots, because at the moment each time you build a robot it's from scratch or it's from parts that have been pre-assembled. So I think robots are probably one of the next big things to take over our lives, such as the computer revolution. So the computer revolution involved putting, first of all, desktop computers in the home, then laptops everywhere, which includes classrooms. And the next thing will be robots taking over every aspect of our lives. So there'll be instead of personal computers, there'll be personal robotics. I think maybe the Econchi robot, the wooden box one that follows you when you're not looking, because it always surprises me, because it stops for about half a minute and does nothing, and all of a sudden it just starts to move again, and it always creeps me out, so it always surprises me. That's what I like about doing robotics and doing computer programming, is the surprises that you get, the unexpected results that can quickly arise. At first I was thinking of doing metal armature, so similar to like a metal-based robot. But it just so happened that I wanted to work out the size and scale, so I didn't just use measuring tape. I thought I'd buy a skeleton and build upon that. But I ended up incorporating that into the work. And in a way it's metaphoric and a bit kind of, it's like a nod to the death of Michael Jackson. Yes, there's currently a robot which has been developed, I think in Italy, which was shared. So it's a 3D designed robot that you can print at home. So all you do is, all you need is a 3D printer and you get the plans, and the plans tell you to print each individual component, and it also tells you how to build a robot. So you can find that online. It's a 3D printed robot. So it'll make things standardized. Yes, you can look up BattleBots. So BattleBots is mainly a US phenomenon, but also happens in Japan. And what happens in these, you build different size-based robots. They're often on wheels and they have wedges and flamethrowers, and also some have chainsaws or circular saws built in. And they're remote controlled, and people have battles in these robots, and there's different sizes and weights that are restricted into the various battles. So BattleBots is very popular. It needs to grow more popular in Australia.